Hi, in this video and the next video, we'll be looking at the following problem. A, B, C, D, E, F, and G, 7 brothers, put their hats in a bag. At random, they pull out from the bag a hat to wear. What is the probability that none of the 7 brothers will put on their own hat? And this problem is an example of a problem from the subject of permutations. And the secret to solving permutations problems is to be very logical in one's thinking through to the solution. So, how will we approach this? Well, my first thought looking at this problem is that's a lot of brothers, and there's going to be a lot of different ways they can put on hats. And so, even not looking at the question itself, I'm just going to ask myself, how many different ways can the 7 put on hats? And the answer to that question will be, for A could put on any one of 7 hats. For B, there are only going to be 6 hats left over. A has put on a hat, so B could put on any one of 6 hats. So far we've got 42 ways, 7 times 6. C has only 5 hats to choose from, can put on any of 5. D can put any of 4, E any of 3, F of any of 2, and G is left with 1 final hat. And when you multiply all those numbers together, it's 5,040 ways. There are a lot of ways to put on the 7 hats. But not in a lot of them, one of the brothers will put on their own hat. And we need to think about how can we express the brothers not putting on their own hats. And what I'm going to do is give you a good notation. So let's just consider an example. Here's A, and A doesn't put on his own hat. He puts on, just as an example, D's hat. Remember that no one's putting on their own hat. D is not going to put on his own hat. He ends up putting on C's hat. This is just a random example. C ends up putting on F's hat. But interestingly, F is going to put on A's hat. So we write that like this. This means A put on D, D on C, C put on F, and then F put on A. And then that's 4 of the brothers. We have to deal with the others. We could have B put on G's hat, G put on E's hat, and then E would be forced to put on B's hat. And so this is a very nice notation. This is called a 4 cycle. 4 hats being interchanged. This is called a 3 cycle. And I have to point out that there is one feature of this notation which can lead to a wrong answer. And I'm going to show that right now. I'd like to compare ADCF to DCFA. So in the first case, A puts on D's hat, D puts on C's hat, C puts on F's hat, and F puts on A's hat. That's the same procedure here. A puts on D's hat, D puts on C's hat, C puts on F's hat, F is A. So although these two writings look different, these are exactly the same permutation. And there are going to be a total of 4 permutations that look different but are exactly the same. I'm writing them out here. That's also the same. And the final one that's the same is F, A, D, C. And we're going to have to remember this over counting when we go on to solve the exact numbers of the problems. But the cycle notation is great. It's given us a way of classifying the different ways the 7 brothers can end up not putting on their own hats. And I'm going to list them out right now. One possibility would be A put on B's, which put on C, D, E, F, and G, it takes all 7 to make a loop, a 7 cycle. And so one way to do it is a 7 cycle. A second way to do this would be A puts on B, puts on C, D, and E, and then F and G. So another kind of structure would be a 5 cycle plus a 2 cycle. All 7 brothers are putting on a different hat. And by 7 cycles, I mean not just this one example, I mean all the different ways I could put the 7 letters. In this number 2, I don't mean just the one I've written, but all the different ways I could put 5 letters in the beginning and 2 letters in the back. The third cycle pattern that would work, that gets all 7, is a 4 cycle, which we already did, and pause the video if you to see if you can come up with a 4th way in which it can be done. The 4th way it can be done is going to be a 3 cycle followed by two cycles. The 4 ways that 7 brothers could each ending up with a different hat is they made a 7 cycle, that's one possibility, a 5 cycle and a 2 cycle. Third possibility is a 4 cycle and a 3 cycle. And there's only one other way you can do it. A 3 cycle, a 2 cycle, and a 2 cycle. And in the next video, we're going to actually calculate the number of ways for each of these 4 possibilities and get the final answer.